Take a deep breath. Seriously, do it right now. That invisible mix of nitrogen and oxygen filling your lungs is the single most important, fragile reason you are alive to watch this video. For decades, astronomers have been staring into the infinite black, hunting for just one other rock out there that can hold onto its air exactly like Earth does. But the universe? It is incredibly hostile. Young stars are basically cosmic blowtorches. They violently strip the atmospheres off infant planets, leaving them as barren, dead, irradiated rocks. We thought this was the inescapable fate for most planets in our galaxy.
Until now. Recently, scientists peered at a world 48 light-years away called LHS 1140b. And what they found didn't just make headlines, it completely broke the internet in the astronomy world. They found the very first confirmed atmosphere on a rocky planet sitting directly in its star's habitable zone. This is no longer science fiction, guys. This is a massive, historic milestone in the search for extraterrestrial life. But here is the crazy part. They didn't find this atmosphere by snapping a neat little photo of alien clouds. They found it by catching the planet literally bleeding gas directly into the void of space. Today, we are diving into exactly how they pulled off this seemingly impossible discovery, what it means for the existence of massive alien oceans, and why this one single observation fundamentally changes the timeline of human history. If you are as obsessed with the mysteries of the cosmos as I am, hit that subscribe button. Let's get into it. Before we talk about the discovery itself, we need to talk about the M-dwarf trap. See, when you picture a star, you probably picture something like our sun, big, yellow, and relatively stable. But our sun is actually kind of a weirdo. In our galaxy, the most common type of star by a massive landslide is a red dwarf. They make up roughly 70% of all stars in the Milky Way. They are small, they are relatively cool, and they are incredibly, almost unimaginably violent in their youth. Imagine a toddler with a flamethrower. That's a young red dwarf, constantly blasting out intense X-rays and ultraviolet radiation. LHS 1140 is one of these red dwarfs, coming in at just about 18% the mass of our sun. Orbiting this angry little star is LHS 1140b. This is a super-Earth. It's 1.7 times the size of our planet and weighs in at a hefty 5.6 times the mass. Now, it sits perfectly in what we call the Goldilocks zone. It's the cosmic version of finding a bed that is not too hot, not too cold, but just right. It means liquid water could technically pool on the surface.
But for years, scientists were terrified that red dwarfs would just strip the atmospheres away from these close-orbiting planets before life even had a chance to start. Without an atmosphere acting as a thermal blanket, LHS 1140b wouldn't have oceans. It would just be a frozen ice ball with a baseline temperature of around minus 47 degrees Celsius. So, finding an atmosphere wasn't just a fun bonus for astronomers. It was the absolute bare minimum baseline requirement to even dream about finding life. So how do you actually prove a rocky planet 48 light-years away has air? You can't just fly a probe there. You have to wait for a transit. A transit is when the planet passes directly between us and its star, causing a tiny, almost imperceptible dip in the starlight. And here is a wild twist. This massive breakthrough didn't come from the $10 billion James Webb Space Telescope. In 2024, lead author Colin Cherubim and his team aimed the ground-based Magellan Clay Telescope, sitting high up in the clear sky mountains of Chile, straight at this star system. They used an incredibly sensitive instrument called the WINERED spectrograph. As LHS 1140b passed in front of its star, a microscopic fraction of the starlight filtered right through the very edges of the planet. By catching that light and breaking it down into specific wavelengths, kind of like a prism spreading light into a rainbow, the team found a distinct, undeniable signature: helium.
But it wasn't just sitting there calmly. They caught helium escaping from the upper atmosphere, trailing into space like a cosmic comet. You might be thinking, helium? Like the stuff in party balloons that makes my voice sound funny? Exactly. Finding this escaping helium was the ultimate smoking gun. It proved that LHS 1140b had a massive, thick envelope of gas and had maintained a primordial atmosphere. And to make it even more compelling, a nearby inner planet in the exact same system, LHS 1140c, showed absolutely no helium, proving it was completely stripped bare and baked by the star's radiation. It was the perfect cosmic control group. This discovery, officially published in July 2026, is a total game changer. Why does escaping helium matter so much to us down here on Earth? Because the presence of an atmosphere means this planet could have a greenhouse effect, just like ours. It traps heat. With an Earth-like greenhouse effect, LHS 1140b isn't a frozen wasteland. It could actually reach a comfortable, borderline tropical surface temperature of around 20 degrees Celsius. Let that sink in for a second. We are talking about the potential for an eyeball planet. Because it orbits so close to its star, the planet is likely tidally locked, meaning one side always faces the blazing star in eternal day, and the other side faces the freezing void of space in eternal night. But right in the middle, at the terminator line where day meets night, the temperatures could be absolutely perfect. The center of that day side could house a massive, liquid water ocean stretching 4,000 kilometers wide. That is half the surface area of the entire Atlantic Ocean, just sitting there in deep space. This isn't just a bunch of numbers on a spreadsheet or a theoretical model. This is a physical place, a world that has successfully held onto its atmosphere for over 3 billion years. It means the exact conditions required to search for biology actually exist on a rocky world in the right temperature zone around another star. We are looking at one of the most practical, promising candidates for habitability in human history. If LHS 140b can survive the violently explosive youth of a red dwarf and hold on to its atmosphere for billions of years, it begs the ultimate existential question. How many others are out there? Remember, red dwarfs make up 70% of our entire galaxy. For decades, we wrote them off as planet killers, dead zones where life could never survive. But if rocky planets in their habitable zones can actually retain thick, protective atmospheres, the number of potentially habitable worlds in the Milky Way just skyrocketed, from maybe a few to possibly billions. This single discovery fundamentally rewrites the math on alien life. It blows the Fermi paradox wide open. Every time you look up at the night sky tonight, you aren't just looking at burning balls of gas anymore. You are looking at a crowded neighborhood. You might be looking at ancient oceans, thick atmospheres, and maybe, just maybe, someone looking back. And the craziest part? This is just the beginning. The very next step for the scientific community is turning the James Webb Space Telescope back toward LHS 114b. Now that we know it has an atmosphere, Webb is going to hunt for heavier molecules like carbon dioxide, methane, and nitrogen to figure out exactly what kind of air is trapped on that world. What do you guys think? Could this massive 4,000-kilometer eyeball ocean be hiding something beneath the surface? Is there life swimming in those alien waters right now? Let me know your craziest theories in the comments below. If you loved this deep dive and want more high-quality space content, hit that subscribe button so you never miss an update on our journey to find Earth 2.0. Thanks for watching, and I will see you in the next one.